Thank you very much. Super fun timeline. Very, very interesting also to get your perspective on it. Amazing how many resources you can just throw at it. I keep being amazed by let's just run a couple of thousand cores on this. One of the things I wondered is for evaluating fuzzers. I like Fuzzbench because it makes it super, super easy to compare and run different kind of fuzzers. I'm wondering a bit regarding the metrics. Like for the Magma work, we try to look at bug triggering abilities and not just coverage. But then bug triggering abilities is very, very hard to infer because you need to prepare the fuzz target in a way that allows you to measure if you've triggered a ground truth bug. And I wondered if there's a way to get the benefits of Magma without actually paying the developer cost of marking or listing the bugs. Or like what other metrics you need to look at. Right, maybe to take a little step back, Fuzzbench measures the exploration stage of a fuzzer, but not necessarily in what kind of diverse ways it can trigger a certain piece of code. And I wonder if you can abstract that or just measure the state space and what part of the state space we have covered so far.
Yes, so if you think about Fuzzbench, right, those are just two kind of metrics we started with, like coverage and bug-based benchmarking, but there are definitely other ways we could be looking at. Like, how about the longer paths that how about the long paths that a fuzzer can cover, or even other metrics, right? So we are definitely looking for your ideas in terms of expanding those kind of metrics we do. And another work we are planning on this front is also expanding the list of benchmarks. So I was talking with Dr. Marcel yesterday, and the problem happens is once you have a set of benchmarks, people start overfitting to it, and that kind of affects the benchmarking in itself. So we are thinking of automating this process, bringing up the OSS Fuzz benchmarks automatically, and maybe making some of them unpredictable to gamify things a little better.
Need to be measured to some extent as well, but are somewhat hard to grasp or capture.
Definitely.
Very cool.
Any other questions? All right. One here and one there.
One thing I wanted to add on the last question was also, like if you look at the Fuzzbench research paper that Jonathan and others wrote, we actually tried to compare different methodologies with respect to like note seeds experiment or trying with and without dictionary. So there are some results there as well. But yeah, we should be supporting those configurations more easily to test as well.
Okay, thank you for your presentation. So you just talked about using Fuzzbench for private evaluation of some fuzzers. There's some actually practical issues. So if I want to use a lot of resources with Fuzzbench on Google Cloud, it is pretty possible that Google Cloud just does not allow me to take so much cores. So do you have any suggestions on that?
I mean, you want to run it privately outside of Fuzzbench on your local?
Not on the local, but if I want to keep my fuzzer private, but I want to run it on Google Cloud with Fuzzbench. This has actually happened to me. So when it was a new Google account, and Google Cloud just does not allow, they didn't allow me to use many cores. Like the allowed number of cores is just far less than what I need for evaluating a fuzzer. So do you have any suggestions around this situation?
We actually have Jonathan, who's the lead developer on Fuzzbench.
Yeah. Yeah, the quota, yeah. Like for new registered accounts, it just does not allow me to require more quota.
Yeah, I mean, also you can also be less paranoid and just give it to us. We'll run it for you.
Yeah, that's exactly what I did. I gave it to you, if you remember.
So ideally, we would want to have for the pre-registration program where then you don't have to worry about the private code at all. And after you just submitted it, then you can run those experiments in public. So that's an ideal state we want to reach so that manual processes becomes completely automated then.
Okay.
yeah, there probably is like some sort of like difficulty in like completely running it on your own, like on Google Cloud without us. But I guess it's like not the biggest priority, right? Because generally people can run it with them.
Yeah. Okay, thank you.
All right, our next question is here.
My question is about not FuzzBench, but the part on improvements of OSFuds that like better concurrent execution and so on. There is a huge problem that is in OSFuds at the moment that was not mentioned in the slide, that is the saturation of the fuzzer. Do you have any plan to unstack all these fuzzers that run on the same program? Maybe if there are no regression, they are not finding any more bugs now. Because I know that most of the bugs in OSFuds are regression that are found in minutes even. Do you have any plan to address this problem of the saturation of the fuzzers?
Yes, so at least in FuzzBench, we provide a mode where you can run against saturated corpora. Like, was your question related to FuzzBench or?
No, to OSFuds. It's like you have fuzzers that make no progression anymore in coverage because there are cannot neither find new bugs and they are stuck, they're saturated. This is a common situation, like you experiment in larger fuzzing campaigns that are continuous, like OSFuds.
Yes, so these kind of use cases happen. What we do there is we kind of lower the weight of some of those fuzzers. So you can actually give more weight to the new fuzzers or newer regressing code. So that's one thing we do. But yeah, that's an open question. What do we do when things get stuck? And that's where Fuzz Introspector comes into picture. Is we would be sending these kind of reports to developers when that happens. And that would give them an idea on like, hey, these are the top 10 APIs you should add in your first target. And it will increase the most amount of code.
All right, Nathan Doughton from Rice. Very exciting talk, very amazing set of results. I have kind of two questions, one technical and one social. I'll start with the social one. So how did you find, convincing people? Obviously, you find bugs and you say, hey, developer, you care about correctness, right? But this is like a systematic set of successes, right? So what's been your strategy for taking a very simple, straightforward idea and growing it into this large kind of systematic, almost field, right, of application?
I would say there are two aspects of it. One is simplifying developers' life. Like, people like to do some things that are really simple to do. Like, think of developers who are writing unit tests, right? They are doing it as part of their development because it's very simple. They are accustomed to it. So our goal was always to make fuzzing as simple as writing the unit test. So that was a way we always tried. And the second reason for our success could be, or not could be, I'm pretty sure the reason for that is continuous feedback that we got from developers, both internal and external, and we kept applying it to improve and automate things. And there were definitely a lot of opportunities in corpus management that we completely automated. And those were much beneficial than, let's say, asking them to improve a broken target for those cases.
Okay, excellent. Do I have time for more? The second question was, what was the thing that helped you to become much more systematic, right? So there's clearly a lot of systematic results here, but you have a large set of experiences. What like one or two things that you did that really helped improve it to a more systematic approach rather than just more ad hoc?
There were a couple of areas. That's where the continuous fuzzing pipeline I was showing. So some of the key features was making sure the builds are archived in a continuous way, because that way they can even reproduce things pretty easily. For an infrastructure, it would really scale easily to just pull in those builds from the cloud storage buckets and run fuzzing continuously. So there were different aspects. There were other aspects on assigning bugs automatically to the regressing owners as well. People really liked it because they would commit a regression, and within a few hours, the bug will get automatically assigned to them. So they would know the bug instantly and fix it.
Excellent. Thank you so much.
All right, maybe time for one or two quicker questions. All right, let's do here and there, and then.
I was just wondering on your own developer community, do you, after doing all this effort, do you get that developers actually, become better programmers, they reduce the bugs, or maybe no more bugs? Do we get that kind of thing? Or that, no, they just rely on you or maybe they stop doing, writing good code and they just rely on you to find the bugs for them, and so on. So this is more an experience thing.
I would say at this point, fuzzing has become extremely simple for them to do less mistakes. The only thing I'm more worried about is like really unproductive fuzz targets. Like how can we make them write better things in the first place? So that's where things like fuzz introspector can kick in. But at this point, I would say writing fuzzers is crazy simple, less than 20 lines of code. And in every ecosystem, even at Google, right? So think about Android, Chrome, or any of the projects, we have made the integration super simple. So they don't need to worry about anything. They just write this 20 lines and can test it pretty easily.
Okay, but then there's the more difficult ones like data erasers and so on, which maybe fuzzers cannot penetrate so easily.
Yes, so that is kind of an active area of research, which is stateful fuzzing. So network protocol fuzzing, that's definitely an area we haven't been exploring much. That's an active area we should be thinking about. Or even like complex formats, right? Like HTML, those things we actually still find black box fuzzers as much more impactful. Like those are not coverage guided, but you would probably do more semantic mutations at the AST level. And that's still much more productive than, let's say, using a byte flipper in libfuzzer kind of thing.
Okay, so let's take one more question.
Hi, I'm Wei Chen from USC, and I would like to, if you could, share any more detail about the future plan about the choke point you just mentioned, whether that's just trying to find the places that are hard to reach, or if you've had any matrix in mind that you can categorize whether a bug is easy to reach, hard to trigger, or just hard to reach, but once we reach it, we trigger it. Do you have any matrix in mind for that?
I mean, you can read some of the details on the OSS, OpenSSF fuzz introspector page, but Navid is there. You can answer any of your detailed questions on the implementation.
Yeah, that would be great. Thank you.